Hi, I'm David Schmit. I'm a metallurgist here in the Metallurgy and Applied Mechanics unit here in WJE's Janney Technical Center.
Hi, I'm Hugh Hou, a petrographer at the Janney Technical Center.
Today, Hugh and I are going to briefly discuss our scanning electron microscope, also called an SEM. This particular unit is capable of magnifications ranging from 30x up to 10,000 times magnification. So this high magnification use of the scanning electron microscope is particularly useful for me as a metallurgist in characterizing metal fracture features such as identifying fatigue in a sample. Another particularly useful tool for this SEM is the energy dispersive X-ray spectroscopy, also called EDS or EDX. This allows us to look at the elemental constituents of particular samples or deposits that we place inside the SEM chamber. This is particularly useful in determining elements that may be present in identifying corrosion or material degradation. Today, Hugh is going to give you a little walkthrough of a recent sample he's looked at and how the SEM and EDS helped him solve for Y.
Thank you, David. Come on in. This core was taken from an airport pavement. Less than 24 hours after the concrete was placed, the surface started to flake. Earlier, I transferred a small amount of the material onto this stump. Now I'm ready to run the scanning electron microscopy analysis. This image shows how the materials looks like using this scanning electron microscope. We have different levels of greenness. One is darker material, the other is brighter material. To get better idea of the chemical composition, I'll run this EDX analysis. This is the spectra collected from spot number 1. The material is mainly composed of magnesium and oxide, and the same for number 2. At spot number 3, we have mainly calcium and oxygen. Combined with the observations from optical microscopy, we concluded the material is a dolomitic lime. It's a mixture of magnesium oxide and calcium oxide. It's the hydration of this oxide that caused this surface distress. Hydration of oxide is an expensive reaction. The volume doubles in this chemical reaction. Now David is going to show how this instrument is helping him solve problems.
Thanks, Hugh. As you just saw with the petrographic sample, I'm going to show you how I use this for metallurgical samples. A common type of sample we get a lot is tubing and piping. In this case, this is a heater tube from a refinery, and as you can see, there's some corrosion and pitting on the outer surface. In this case, the client wants to know what is causing the pitting and what they can do to prevent that in the future. So what we will normally do is take a sample like this and we can cut it on a saw and downsize it to something that looks like this, which we can then place in the SEM chamber, or we can scrape off some deposit and put it on an SEM stub with some carbon tape and take these and put these in the SEM. In this case, we are looking for particular elements that are known to be corrosive towards certain metal alloys. Usually we're looking for elements like chlorine or sulfur. So this is our deposit sample that I put in earlier, and as you can see, we're seeing a little chlorine peak, which indicates that there may have been some kind of acid like hydrochloric acid or other corrosive substances present. So we can take this information and include it in our report to the client, where they can do a more thorough evaluation of where this potential corrosive substance could be coming from and potentially prevent it from happening in the future. As you can see, our scanning electron microscope is a powerful piece of equipment used by metallurgists, petrographers, and chemists. The high magnification capabilities, along with the elemental composition analysis, is key in helping us solve our clients' problems.
Thanks for stopping by the Janney Technical Center.